to discuss a model solution to the superhero coursework, so the coursework 2. I'm going to take you through the model solution to this, or at least the solution that I was looking for. So what I was asking for when I released the assignment and when I set these questions for you. First of all, I want to make a general point about the format of these assignments. So some of you have emailed me and asked for me to be more specific in the requirements that I'm giving you. Now, I'm reluctant to do this because remember, these assignments for your own benefit are a test of your understanding. So you can evaluate your own performance, so we can evaluate your performance. And if I simply give you a step-by-step guide like we have in the lecture, so implement this method, do this, implement this procedure from object-oriented programming, then that's not so much a test of your understanding, but a test of your ability to go back through the notes and find the relevant syntax. So I'm not trying to catch you out by doing this, I'm not trying to be purposely vague, but I really want to test your understanding, test your ability to apply the concepts that we've taught you to new situations. And if I simply give you a step-by-step guide, then I'm not really going to achieve that. So there's a reason that I give you these requirements, and not rather than a step-by-step guide, because I want to test you. I want to prepare you for the final exam. And actually, if you look at the past papers, you'll see that in your final exam, you'll be asked a very similar question to the one you find in assignment 2. So you'll be given a scenario, and you'll be asked to model this in code. You'll be asked to model this as an object-oriented program, but you actually won't be given a set of requirements. Okay, so this is to break you in gently, so to speak, to the process of object orientation. So these requirements shouldn't be expected. They should be perceived as hints. They should not be perceived as standard. Okay, so yes, it would be nice to give you a step-by-step as you have in the labs, but remember, this is an assessment and I want to prepare you for the final exam. Okay, so let's dive into modeling the second solution then. So if you open up your assignment, you'll see we have this little scenario. So in this case, the superheroes that I'm going to model are Captain America and Iron Man. So we have this little scenario that says that basically says the pair of them are fighting, there's a dispute between them, and based upon their individual strength, we need to determine who will win the fight. Okay? So the questions themselves are split into two set of requirements, and each of them pertains to a different file. So the first one here is superhero, and if we skip through to question 2, you'll see that second is fight. Okay. Now, skipping ahead to question 2, it says create a class called fight, which can be compiled and run from the command line. Okay. Now we know when we compile, if we want something to be run from the command line. So if we want something to be runnable, so to speak, if we want to be able to write javac fight.java and then write Java fight and have something happen, then this class needs to have a main method, okay, which remember is the entry point into the class. So public static void main, this should be really familiar to you by now. This is the special method that we enter, which will be the entry point into our program. This will be where all the code is run from. This should be extremely familiar to you now. And you can see that I've said explicitly it should be compiled and run from the command line, so we know this main method has to be here, okay? So before I do anything else, I'm going to put this main method in, so I know this is the class that's run. Okay. Now note, for superhero, I don't say this. I don't say anything about it being runnable, which suggests that there's no main method in here. Okay. So this is just a class that can have objects made of it, but not inside the class itself, inside somewhere else. Okay. So my immediate implication is that superhero is just a template for an object. It's not going to have, it's not going to be run directly, but instead it's going to be run from a main method somewhere else, and that place is inside fight. Okay, so a good thing to do when you're faced with these requirements is to first get a basic structure of your program. So have a quick scan through the whole assignment and you can see, okay, I'm being asked for 2 classes. It's clear that one has a main method, and now remember, we only, in most cases, only have one main method in our sort of object-oriented ecosystem. So in our set of classes, which are going to be in the same folder, different files in the same folder, we usually only have one method that one main method, so one driving class, which in this case is fight. So we understand that we have this structure to our system. Okay, so one class called superhero, no main method in here. We don't expect to be able to run this class directly, but instead inside this separate class fight, we know we have this main method where we can create objects of superhero. Okay. So, question 1, model this scenario based upon the following requirements. So, create a class to represent a superhero. We've done this already. We've already had a quick scan through. We know how we're going to divide our code. We're going to divide it between 2 classes, 1 superhero, 1 fight. And the first sentence says this, so create a class to represent a superhero. So one subtlety that I like to put in these assignments is I use a slightly different font, if you can note here, every time I'm referring to a class, okay? So here I'm saying create a class to represent a superhero, and I've used a slightly different font here. So you know, or you should learn that every time I use this font, I'm referring to this class. Okay, this is a subtlety, and you can obviously complete these requirements without noticing that, but this is just that extra hint to you that when I use this font, I'm referring to an actual class. Again, there was no need to understand this to get full marks on this assignment, but just note for the future, this is an extra little hint. Okay, so create a class to represent a superhero. This is done this already. Next sentence within the same requirement, every superhero has a name. Okay, so we know that inside superhero I need to store some information, obviously information that every object that I create of the superhero class is going to have, and this information is name. Okay, so we've seen lots of examples of this before. We know now if we want to store some information in a class, we need a field. Okay, how do I write a field? Well, a field, remember, is just a variable essentially that is inside the class, and we might say that it's sort of floating around inside that class. Obviously, to define any kind of variable, I need a data type and I need a name for that variable. So every superhero has a name, so I know I need to define name. The most natural variable type for name is obviously a string, so I write string, and then I obviously need a name to refer to this variable, so I'm going to call it name. Okay, so here I've declared a variable, it's of type string, and its name is name. So I'm creating a place in which to store data, and I'm naming that storage place, this variable location in memory. I'm referring to it with the variable name name. So remember one last thing, all fields have to be private. So I know at least at the point of the time in which I'm making this video, I've not yet released the nuclear reactor example. I am in the process of doing this, but lots of you will have seen me talk through this example, and this explains why fields have to be private in quite a neat way. So look out for that example on Keats. I'm sure if you're watching this a few weeks from its release, that will be available now. So go on Keats and have a look at that, and that will explain why fields have to be private. But the basic idea is we want to hide as much of an object's or a class's or an object from which a class is made. We want to hide as much of the state inside that class as possible. So we want to hide the variables, of course, within which you contain the state of an object. We want to hide that because we don't want people to be able to manipulate the state of an object directly. We want to mediate that manipulation, and we can do that by making our variables private and instead setting the values in those variables via methods. Okay? So the requirement here says every superhero has a name. So I've defined a place in which to store a hero's name. Now this is not enough to fulfill this requirement, okay? Because the language here is very subtle, very important. It says every superhero has a name, okay? If I were to simply define a field like this, then there's no guarantee, and indeed in this case no way, a superhero can have a name. Okay, so let's go inside fight, let's make a superhero object, let's say superhero my hero equals new superhero, like this. Yeah. So here you can see that I've created an object of the superhero class. Remember, when I create an object, I simply tell Java find this name, so find superhero wherever it is, in this case in the same folder in a different class. It finds superhero, it takes a copy of all this code and it stores it inside my hero. Okay. Now inside this copy, obviously name is blank, okay? It's equal to null, it's equal to nothing, because nothing is assigned to it, okay? So this in itself does not fulfill the requirement that every superhero has a name, because I'm able to make objects of this class without specifying the hero's name. Okay, so this does not fulfill this requirement. This would fulfill a requirement that would be something like provide the opportunity for a hero to have a name, or a superhero may have a name. Okay, there's no way we can enforce that every superhero has a name, which is what the requirement asks us for, in this current setup. Okay, now we know that the only way we can force information to be given to a class when an object is made of it is via a constructor. Okay, so by examining this requirement, you can see that we have to have this information, so we know that we must use a constructor. Okay. Remember that all a constructor is a special kind of method that has no return type, so you simply start with public, there's no return type. We just launch straight into the name of the method, which has to be the same as the class. So in this case, just public superhero. Okay. And like all method calls, we know that if we put some arguments in these brackets, so if we define a variable, so to speak, inside these brackets, then that's information that has to be passed to that method in order for it to be called. Okay? So a constructor is a special kind of method that's made every time I make an object of a class. So effectively what I'm doing in this statement here that I've highlighted is I'm calling the constructor. Okay, you can see this because the definition of the method is the same. Okay, so when I write new superhero, I'm effectively calling this method while at the same time making an object of that class. So taking a copy of superhero and storing it inside my hero. Okay. So because this is a method that has to be called every time I make an object of a class, then if I define some restrictions, so for example, I always have to pass some information to my constructor, then there will be no way of creating an object of this class without passing that information. Okay? So what I can do is I can say that here, I can say string name, like this, for example. And now see, I have Eclipse is handily telling me here I now have an error. Okay? So I can't actually make a superhero without supplying a string. Okay? So what I'm now saying is I am now actually fulfilling this requirement because every superhero has to have a name while I'm fulfilling it in part. So I'm now saying that there is no way to create a superhero object without supplying a string. Okay, so I'm now starting to fulfill this requirement that every superhero should have a name. The last step that we're familiar with is to now assign this information. So I pass this string name in, and as we know, any information that I pass when I call a method is stored inside the argument, so stored inside the argument variable. Then every time I refer to that, then I'm accessing that information, and in this case I can store it in one of the fields. Okay, so let's say that my superhero is called Martin, for example, not to big myself up too much. Let's say that I pass this string Martin through. Then what will happen is obviously the value inside name here will receive Martin, because we know that when I pass some information to a method, then the arguments or the variables that are declared inside the method definition here, inside the brackets, they receive the value that's passed. Okay, so we now know that the value inside name, is equal to Martin. So what my definition here is effectively saying, obviously this isn't real code as you can see from the error. What this is effectively saying is the value Martin is going to be stored inside this string name variable. Okay, and now obviously I know that down here name is equal to Martin, so this should effectively read Martin, which obviously means therefore, because I'm assigning the value Martin up to the field here, that effectively this is now the information stored inside my class. Okay, so this is, as many of you will have already seen, this is the basic use of classes. Okay, the basic reason that we make objects of classes is to define this storage location, and we're defining a means by which to pass information to this class. Okay, so by defining this variable string name, by providing arguments, I'm providing a way in which I can pass information to my class. Okay, so every time I supply the string Martin here, it will that value will be passed inside name here. Obviously, because these variable names are the same, it will come down here and be passed to name here. It will then be passed over here to the field name, to a reference to the field name, which will then be passed up here and obviously then stored inside my class. So I'm providing a way to store information inside my class. Now, one optional part of code that I've opted for here is to use the this command, okay, which has absolutely no requirement for you to be familiar with this. You were not penalized in the coursework if you didn't use this. Of course, you were penalized if you used it incorrectly, but if you omitted it, that's fine. Because what it provides me with is the ability to differentiate between parameters here and between fields. Okay, so obviously you can see Eclipse has handily colored them in different ways. So because I'm defining an argument here, because my argument is called name, because that's the same as the field, then if I wasn't to include this, then Java would get very confused and it wouldn't know necessarily if I was referring to name up here or if I was referring to name here. Okay? What it would actually do is make the assumption that I was only referring to name inside the arguments here. Because obviously this is the closest variable, it's the one that's inside local scope, we say. So it would just assume that I was referring to name here. And obviously this isn't very useful because I'm simply therefore assigning the value in name to itself. As you can see, they've both turned brown here. So we can see this is actually fairly useless because there's now no way that I can assign the string that I've passed to the field. So I'm not achieving the storage capability that I want to add to my program by adding this way to pass information and store it inside a field. Okay. So I overcome this issue by using this. Okay, and what this explicitly tells Java is I'm not referring to name up here, but I'm in fact referring to name that's defined inside this class. So what Java will do is it will come to Superhero and it will find the first instance of name, which in this case is the field name, and it will therefore know now that I'm not referring to name up here, but I'm actually referring to the field name that's defined inside this class. Okay. Now, there is another way to get around this, of course, which is to explicitly differentiate between these values. So I could call this something like name2, and I could call this name2, and then Java would know that what I was referring to, obviously, because the names are different. Okay, the variable names are different. Now, you might ask, well, why can't we always do this? Well, again, it's a style choice. So I don't like lots of different variable names. I like to keep things consistent. And name2 looks a little ugly. To be honest, it looks a little, I don't think it makes the code particularly readable. So to get over this problem, this is why I use this. But of course, as I say, there's absolutely no requirements for you to do this. If you refer to do something maybe like n here or n here, so you're naturally differentiating between the variables, that's fine. There's no problem there. But as I say, I like this because it feels much neater to me at least. Okay. So let's go back to the requirement. Let's think about why we've done this. First of all, by adding this capability into our constructor, by providing the ability to specify a superhero's name, we have provided a way, this classic way that you should be familiar with now, the classic way to pass information to a class or to pass information to the object that you've made of that class, is to provide a storage place in which to keep information, which is the whole point of object-oriented programming. At the most fundamental level, is to provide a place in which to store information. Remember, objects in their simplest form are simply fancy variables, fancy places in which we can store multiple pieces of information. Okay, but by doing this, we've also fulfilled the part of the first requirement, which is that every superhero has a name. Okay, because we've said there is only one way now, in this code at least, to create a superhero object, and that's the way in which I pass it a string, which we now know is going to be used as that hero's name. Okay, so if I were to remove this, as we've already seen, there's an error. I cannot make an object of this class without giving it a string, which we assume that the user is going to use as the name of that hero. Okay, so there is no way of me creating an object of this class without providing it with a string which is going to be used as that hero's name. Okay, so we are now fulfilling the requirement that says every superhero has to have a name. Okay, so let me reiterate, there was, without adding a constructor, without having a constructor which enforces the fact that I have to supply a string when I make an object of this class, you cannot fulfill the requirement that says every superhero has a name. Okay. Now, next sentence. Every superhero can also have a strength, but this should be optional. Okay. So there are lots of different ways to do this. One of the ways that people thought to do, well, initially, of course, the first thing we have to do is we now know that we have some additional information to store about our hero, so we have to define another field. Okay, so in the same way we had a string to store the name of the hero, we now need somewhere to store the hero's strength. So I'm going to define a new integer field, and I'm going to call that strength. Okay, so every time you're told that you have to in a class you have to store some information, then we obviously need a new field. Okay, now we can have an arbitrary number of fields. Remember, classes are, in the basic form, are just places in which to store information, and the amount of information we can store is as much as we want. Okay, we just need a new field every time we want to supply or store some new information. Okay, so when I see that every superhero can also have a strength, I know that I have to define this field. Okay, so I might think to myself, well, what's the way in which I can supply the hero's strength? Well, I could just supply that information in the same constructor, couldn't I? So in the same way that I input name here, remember we can have as many arguments as we like inside a method call. Remember, a constructor is just a type of method that's called every time I make an object of that class. I could just simply add strength in here as well, okay? And then I could say Martin had a strength of 5, not very strong at all. So what this would do, this would provide me with a way to pass information about the strength to my class, but this wouldn't fulfill this requirement, okay? Because it explicitly says that this should be optional. Now, because I've put 2 parameters here, it's not optional, okay? So imagine I didn't want to give Martin any strength, then I couldn't do this, okay? Because remember, every argument that I have inside the constructor enforces that this type of information should be passed, okay? So there's now no way to make a superhero without giving it a name and strength, okay? So when you define parameters inside the constructor, this is the information, this is the type of information that has to be passed to your class, okay? So there's now no way to make a superhero without giving it a strength, so that doesn't fulfill the requirement, okay? So we know that this is not an option, okay? But remember, what we can do is we can have multiple constructors. So we can have multiple ways in which someone can construct objects of our class, okay? So we could simply effectively have as many of these superhero definitions as we want, okay? So I would say that the neatest way to fulfill the requirement that strength is optional is to have 2 constructors, okay? The first constructor, all you have to supply is a name, so you have the option to supply only a name when you create a superhero object. But in the second constructor, we could have the option to supply a name and to supply a strength, okay? So what we do is this. We know that every superhero has to have a name, okay? So we know that in order to retain our fulfillment of the first requirement, every constructor has to have this string name in it, doesn't it? Okay? And then once again, we can do this dot name equals name, okay? So we've added the second constructor in, and we're still fulfilling this requirement because there's still no way to create an object of superhero without supplying a name, okay? But note here that there's now an error, of course, because Java has no way to differentiate between these different constructors, okay? Remember that when we call a method, we're not just looking at the name of the method, we're also looking at the parameters that you supply, okay? And because the name of these methods or these constructors, of course, they're types of method, is the same, and the parameters are the same, 2 string variables, then Java actually has no way to differentiate between these constructors, okay? So this is not allowed. So what we have to do actually is differentiate between these methods and at the same time fulfill our requirement, which is that strength can be optional. Okay, so I'm actually going to add, like I did before, int strength down here. Okay, and then I'm going to, as you should be familiar with now, assign this strength value to a field. Okay, what am I saying here? Well, I'm now saying that there is 2 ways to construct this object. The first way, or either way that you choose, you're going to have to supply a name. Okay, because in both constructors, you always have to supply a name. Okay, so there's 2 different ways in which to make objects of this class, but because I've said in the argument definition for both these constructors that you need a string name, you always have to supply a name. Okay, but strength is optional. Okay, because if you wanted to, you could simply create an object by just supplying the name. Okay, so in this case, I've said Martin. Okay, strength is optional, so I'm fully able to make an object of this class by just supplying the string name. That's fine. But what I've provided here by putting in a second constructor is the ability to also create an object of this class by supplying an integer. Okay, so if I wanted to, I could also give Martin here his feeble strength of 5. Okay, so look, there's no error. Eclipse is telling me this is fine. That's because I'm now calling this second constructor. Okay, remember that we match methods or we match constructors by looking not only at the name, but at the types and number of arguments given. Okay, so I'm now calling the second constructor, so I'm able to supply a strength value, and that will be assigned up here. We can see obviously strength here corresponds to the strength variable here, and because I'm using this, I can tell Java that I'm referring to the field up here. So that value will be assigned to strength, but it's optional. Okay, it is optional. I do not have to supply this value when I make an object of my class. Okay, so this neatly provides you with the ability to supply that value. There is a different way to do this, which I know that some of you have done, which involves not setting the strength through a second constructor, but but actually defining a separate method to do this instead. So something like public void set strength, which would accept an integer value as the strength in the same way that the constructor did. Then it would say this dot strength equals strength. Okay. Now this is fine. It achieves the requirement. Obviously, strength is now optional, but of course it is slightly more code. So I now have to explicitly say my hero dot set strength equals to 5. So there's the additional line. It is slightly less efficient, and in many respects it's less elegant than using a second constructor. So let's move on to the next requirement. So let's look back at the question sheet. So question 1a, we're still working on this. So if a superhero does not have a strength, their default strength should be 10. Okay. So to fulfill this requirement, we have to look at our two constructors and we have to say where would we set the default strength. So in what case would a strength be default? So what I'm saying here is if the strength is not provided, so if a user doesn't specify a strength, then the default value inside the strength field should be 10. Okay, so I'm not telling you to manually set the strength to be equal to 10 at any point. What I'm saying is if nothing is specified, if no strength value is set, then the default value should be 10. Okay. Obviously, the natural place to do this is inside the first constructor, which is the constructor that's called, obviously, when no strength value is specified. So we might say something like strength equals 10. Okay, so this is when if someone were to not provide a strength value, so here if you're just making a superhero with the name Martin, you're not supplying any strength value, so this would automatically set the strength value to be equal to 10. Okay. Something I also saw people were doing was setting the strength value on the field itself, so saying private int strength equals 10. This may feel, I guess, more natural because you're used to both defining and initializing variables. It might make more sense to do it there, but Josh has kindly gone to a good deal of length on the forum to explain why this is slightly less efficient. We've also talked in lectures about why stylistically it's nicer to set your default values inside the constructor. So it's nicer to explicitly say for someone reading through your code that when the strength value is not set in the constructor, we're going to set the value inside the strength field to be equal to 10. Okay, so this will have the same effect. This will set the strength value to be equal to 10, but as you can see from Josh's post, this will actually happen slightly before the constructor. So when either constructor is called, it will set the value in the strength field to be equal to 10 and then reset it later on. So there is that extra bit of inefficiency. And as I say, just stylistically, it's nice to remind you and anyone that's reading your code that the default value of strength here, done it again, should be equal to 10. Okay. So to fulfill this requirement, we're going to set the strength value to be equal to 10 and we're going to do this inside the first constructor. Note that I don't have to use this. Okay, so it's important that you demonstrate that you know when you have to use this and when you don't have to use this or the command this. This is because there's no conflict here between the names, the names that you've chosen. Java knows that I'm referring to strength because there's only one place in which it can see strength, and that's up here in the field strength. Okay. Remember, this isn't the same for name because there are two instances of the name variable. One that's in local scope here, which is inside the arguments that are passed, and one that exists as a field. Okay, so I have to use this here if I want to use the same name for my field and for my parameter. Okay, but for strength, because there's no strength parameter, there's no confusion here between Java that Java has between the names that I've chosen. Okay, there's no conflict, so I don't have to use the command this. Of course, that means if for whatever reason I wanted to instead provide the default strength down here, now there is a conflict, okay, because strength is defined here and up here, and Java doesn't know to which one you're referring and makes the assumption that you're referring to the local one, which is in the parameter. Okay, so here you would have to use this. Okay, hopefully that makes sense. Okay, so that should be the first requirement complete. Okay, and this requirement was worth a good bulk of the marks. It was worth 5 marks. So this is really what everyone should be expecting to do to go a good way towards getting a good grade in this piece of coursework. This is the fundamental part of the assignment. You should be able to understand how to do this. You should be able to understand how to use fields to store data, and you should be able to understand how important constructors are in defining the way in which a class can be used. Okay, and let me just re-emphasize for you the way in which I'm going to call the two constructors. So I'm going to have a second hero here, and I'm going to call this hero Derek, and I'm going to give him a strength of 100, okay? So I just want to re-emphasize the way that I call these different constructors, okay? So Java will find here superhero, it knows that I'm referring to the superhero class, but it can see that I'm just supplying one string, okay? So it knows that I'm only referring to this constructor here. In the second instance, when I define my second hero, I'm supplying two pieces of information. So Java knows that I'm looking for a constructor that accepts two pieces of information. The first is of type string and the second is of type integer. Okay, so it will come to superhero, it will look for a constructor that accepts a string and an integer. Okay, and if I wanted to, I'd be perfectly within my right to not supply any strength. So obviously strength is optional, like that's absolutely fine. You can see there are no errors. But remember, of course, I have to give every superhero a name. So I'm not allowed to not give my superhero a name. Okay, so this fulfills nicely the first requirement in question 1. Okay, let's move onwards. Let's talk about power up. Okay, so the next requirement says every superhero can receive a power up whereby their strength is increased by a specific amount. Okay, now this was quite straightforward, I think. All this is asking you to do is to provide a means by which we can manipulate an existing strength value. Okay, so we know because these fields are private that I can't do something like this. I couldn't do something like my hero dot strength. I couldn't access this field directly. So again, this is an error. Strength is not visible is what Java will say because it's private. And remember to review the nuclear reactor example to work out why that is. Okay, so you cannot simply set the strength like that. Your field should have been private. Setting the strength like that is not sufficient for a nice object-oriented program. Okay, so instead, because we know we have to update the strength value, we're going to provide another method. Okay, so again, you can see this font that I'm using, power up. That suggests that power up should actually appear somewhere in your code. Okay, so again, you didn't have to know this for this assignment, but just beware in the future that when I use this type of font, I'm suggesting this is actually something that you should use in your code. Okay, so I know I want a method called power up. Yeah, I know that all methods have to be public. And now there isn't really anything immediate that should be returned from this method. All we know is that we're updating a value. So I'm going to make this void. Okay. But what I do know is that the superhero strength should be increased by a specified amount. Okay. And the way that you specify a value when you've created an object of a class, when you want to manipulate an existing stored value, the way that we know that we specify something is through the arguments, as we've already seen. So I create an argument, I'm going to call it int power up, like this, or perhaps a more natural name would be something like strength increase, just to avoid confusion. I'm going to create an argument called strength increase, which remember is just a variable that I declare inside the method definition that's going to accept, receive and store any values that I pass when I call this method. Okay, so what I'm doing here is I've created a way in which to call this method and in which to supply this strength value. Okay, now if I want this value to influence my existing strength value, then I'm going to have to in some way store this value. And remember, now we want to increase the value. We don't want to replace what's in the strength field. So if I was to do something like strength equals strength increase, this would be wrong, okay, because it says I want to increase the value by a specified amount. Okay, and this was made clear. I put this in italics just to emphasize that. So let's take a step back. So we know that we want to update a field. We want to update something inside any objects we make of this superhero class. So to do this, we know we need to make a method. We know that the only way we can interact with private variables, with private fields, is to somehow supply information to our class. We could do this by having parameters that are passed to a method. And we know that if we want to influence the stored values, if we want to change the stored values, we have to use equals. So we have to say, find my field strength and change it to be equal to whatever's passed in. Okay, and this would be fine if it was something like set the strength of the hero. So I showed earlier a method called setStrength, which would update the strength value based upon something that was passed. That was fine for setting the strength optionally, but for power up, we know that we're not going to set the strength, we're in fact just going to change the strength. Okay, so we want to take the strength value that we already have, and we want to add the strength increase to it. Okay, So if you think about this logically, what we effectively want to say is we want to take the existing strength, so strength, and add to it whatever the strength increase is. Okay, so take the existing strength and add whatever to it whatever the existing, what the new strength is. Okay, and then what we want to do is we want to take this new value and we want to reassign it to strength. Okay, so imagine that the value inside strength was 10. We want to add in a strength increase of 20, so the result of this operation is 30, and we're then going to override what strength was before, which was 10, with the new value, which is 30. Okay, hopefully that makes sense. So what this is saying is take what strength was, add the increase to it, and then save it back inside strength. Okay, so obviously the initial strength value therefore is lost. Okay. As many of you realize, there is a quicker way to do this. Java provides a nice shortcut to do this, because this is something that has to happen a lot, which is actually not to say this statement explicitly, but just to instead do this shortcut. So what this is effectively saying is exactly what I wrote before. It's saying take strength and increment it, add to it whatever the strength increase is. Okay. So I don't think too many people struggled with this question, with this requirement. So it's hopefully quite obvious how to power up a superhero. Doing something like math.abs here was a really nice touch. I'd like to see people doing that, because obviously this accounts for the fact that people who are using your class in the future might not know the rules, and they might try and mess with it by providing a negative strength. So math.abs here was a nice touch, but obviously not required. But it was a nice touch indeed. Okay. So perhaps it's worth noting that the place that people might have struggled most actually was what to return. Okay, so do remember that if you don't feel like there's any need for your method to give you any information back, if it doesn't feel natural for your method to give any information back, then there's absolutely no need to do so, and we can simply write void here. Okay, I know some people might have written something like int power up here and done return strength or something similar to that. There was no requirement to do that. Okay, if it's fine to not return anything from a method such as this, which we effectively call a setter. I mean, it's not really in this case because we're not setting, we're actually incrementing, but a method which simply updates or sets a value we commonly refer to as a setter. There's really no need for a setter to return anything, so you're happy to leave this void. Okay, and obviously if it wasn't void, then you have the awkward question, which is, well, what does this method return in this case? There's nothing natural for it to return, so you end up doing something unnatural, like returning the strength. Okay. Now, the next question was fighting the superheroes. Let's just have a look at what power up would do. So obviously, if I had my hero, then I could do power up, and I could give it something like 1,000. Okay, so here I've powered myself up. So I now, maybe been to the gym for a few hours, I now have a strength of 1,000. Okay, so this is the natural way in which you can call this instance of the class and manipulate it in some way. Okay, so please, if you're not familiar with the idea that I can make 2 copies of the superhero class, store them in different variables, and then manipulate those copies separately. So for example, the strength inside my second hero in this setup will remain 10, while the strength inside my hero will be changed to 1,000. If you are unfamiliar with that, if it seems strange that I've only got one strength variable, yet I have different copies of it, if that is unnatural to you, please talk to me, please email me, because I want to explain this to you. This is a fundamental principle of object orientation. But I think at this point, most people understand that. Okay. So now I want to talk about the ability to fight superheroes together. Now, we're getting now to the harder parts of the coursework. If you were able to demonstrate this, and then you were able to demonstrate many of the things from inside fight, you should have got a reasonable grade, you should have got a good grade for this assignment. But it's inside fight that I'm really starting to test some of the perhaps more subtle elements of what we've talked to you about so far in PRP. Okay, so let's look at requirement 1C. So every superhero, note this special font again, so I know that I'm still inside the superhero class, has the ability to fight another superhero. Okay. And we know that methods provide us with the ability to do things. Okay, so there's a very large suggestion here that you should have a method called fight. Okay, so we know that there's the heavy suggestion here, and it actually makes sense in this case to supply a method called fight inside superhero. Okay, now I know some people chose to, in fact, fulfill the fight code inside the main method. But of course, this is a slightly inefficient way to do this. Okay, so it would be, what we could do is we could fight the superheroes together here. We could maybe use a get method to understand their strength and to compare them in here. But hopefully, as you'll see as I program the fight method, this is quite an inefficient way to do this. Okay, because if I instead write the fight code inside here, if I instead compare two superheroes' strength inside the superhero class itself, I can fight as many different instances of the superhero object class, as I want to. Whereas if I was to simply do the comparison of strength inside here, I'd have to repeat the code a lot. Okay, so I'd have to do lots of repetitions. Okay? Instead, if I have this nice, neat method fight inside the superhero class, then I can use this code. I can call this method as many times as I want, and this is actually the most efficient way to do it. So this is how people maximize their marks. Okay, so let's assume we have a method called fight. Let's make it void for now. Let's call it fight. Let's define this as such. So we now know that every superhero has the ability to fight. So I have the ability to say something like my hero dot fight. Okay, so I've now provided the ability, which is just another way to say a method that can be called inside superhero, and I can call fight. Okay. Obviously, this is quite a useless method at the moment. Yes, I can call it. It doesn't do anything. It doesn't accept any information. It doesn't return anything that I might like to use in the future. Okay. So the next sentence says, the result of this fight is the winning superhero. Now this is somewhat subtle, but let's think about this. So the result of this fight is the winning superhero. So what do I mean by result? Well, I mean the return value. Okay, so the result of this fight is the winning superhero. So what I immediately know, or what I should know, is that what I actually want written here is superhero. Okay, so I want the result of the fight to be a superhero. So in other words, I want this method to return an object of type superhero. Okay, so I want the result of the fight to be a superhero. Now, some people interpreted this as, or interpreted part of this requirement as simply printing the winner out. Okay, note that I don't actually say anywhere inside question 1, I don't ask you to print anything. So it's not a requirement to print anything. So I don't ever say here, I don't say print me the winner of the fight. Okay, now some people misinterpreted question D as asking for this, but I'll come on to that in a moment. But aside from here, I in fact don't ask you to print anything. So at no point in requirement C does it say to print anything. So you did lose marks if you printed the result here. Okay, and we'll see why as we develop this fight method. Okay, so I didn't actually ask for anything to be printed inside superhero. I just want superhero to be a template or a storage place where I can retrieve information from, and I can print the result later on. I can print the result somewhere else. And the reason this is, and we'll see why in detail, but the overall reason that this is for reusability. Okay, so when you print things, you lose them, they're gone. But if you instead return things, then you have them available for you to use in the future. Okay, so let's go back to the requirements. The result of this fight is the winning superhero. Okay, so I know that I want the fight method to return something, an object of type superhero. Okay, now it might seem strange or unnatural that I can actually refer to this type from inside my actual definition of the class. So it might seem strange that I can refer to superhero inside superhero, but that's perfectly fine. Okay, when I define public class superhero, I'm defining my own special type. So I can use, therefore, superhero any place that I would use a regular variable type. So in the same way that I would write in here, I'm more than within my right to write superhero. Okay, because every time I make a class, I'm making my own special data type. Okay, so everywhere a normal or a primitive type would be used in Java, I can instead replace it with what we call an object type. Okay, so I'm fine to write superhero here. Okay, so I know now that I have to compare two superheroes together and find the winner. Okay, and the only way I can do this is obviously if I have access to another superhero. Okay, so the motivation for this or the inspiration for this should have come from the noughts and crosses example, where you can recall that we compared two pieces together, didn't we? So we said, is this piece equal to another piece? And you saw there how the actual parameter to a method was of the same type as the class in which it was defined. Okay, so this was another thing that we found in the bank account example. So when we wanted to compare two bank accounts together, we saw that the information that we actually passed to the method was of the same type as the class in which it was defined. Okay, so what I'm saying here is not only do I want to return a superhero from this method, I actually want to give this method a superhero, which will actually be the opponent that I'm going to fight against whichever object is represented within the current class. Okay, so if I type superhero here, opponent, then I know that whichever object I invoke fight upon, whichever object I go to call the fight method, can accept a different superhero object. Okay, so we'll see how all this flows in a minute, but let me say that again. So I am at some point in the future going to invoke fight on a specific object, in this case my hero, and I now know I can pass it a second object of that class. Okay, so fight in this case, remember these are two separate copies of the same class. Fight in this case is being called upon my hero. Okay, so the actual method that I'm referring to, the copy of the method that I'm referring to, exists inside my hero. Okay, so there's one copy inside there. What that means is my hero, inside my hero expects to receive a different superhero object. So I'm more than within my right to pass it a second object. Okay, what this means, of course, is this can happen any way around. So I could actually do my second hero.fight and instead pass it my hero. Okay, so I can arbitrarily pass different objects of the same class inside one another. Okay, so this is a very subtle concept. It's all built on the idea that I can have multiple, or I expect to have multiple objects of the same class made. So I'm fully within my right to say that the only way to call the fight method is to pass another object of that same type. Okay, so fight expects to receive a superhero called opponent. Okay, so I know from these requirements, so I know that every superhero has the ability to fight another superhero. So that immediately suggests to me, okay, the value that I need to supply is a different superhero. So I expect for this method to receive a different superhero object. So I fulfill that requirement by adding this parameter here. And then I know that the result of the fight is the winning superhero. So I know what I have to pass back is a superhero object. Okay. So now let's go into the dynamics of working out which superhero to return from this method. Okay, and it's actually simple in this case. The winner of a fight is determined by which hero has the highest strength. Okay, if two heroes have the same strength, then the opponent wins. Okay, so all I need here is a very, very simple if statement. What I want to say is if the strength of the current superhero, so the superhero upon which fight is invoked, which in this case is my hero, if that strength is greater than that of the superhero which is passed in, which in this case is my second hero, then the winner will be this current object. So the current object upon which fight is invoked, which in this case is my hero. Okay? So it's a simple if statement that says if strength is greater than opponent dot strength, yeah, then what I want to do is I want to return this. Okay, let's go through exactly what's going on here. So I'm saying if strength, so we know that because we're not prefixing strength with anything, we know that there's an implicit this dot strength, so we know I'm referring to strength inside the current object upon which fight is invoked, which in this case is my hero, and I've not set a strength for my hero bar the power up. Let's get rid of that for now. So I've not set a strength for my hero, so I know that's going to be 10. Okay, so if strength is greater than opponent.strength. Now what am I doing here? Well, I've extracted the strength from the current object, so the object upon which the fight method is invoked. What I'm doing here is I'm extracting the strength from the past object. So I'm taking the strength of the current object, so for example my hero, and I'm extracting the strength from the past object, which is my second hero, and I'm comparing them. Okay, so what I'm saying here is I want to take the strength value from one object, which is the current object, and I want to compare it to the strength value in a different object. Okay. Now note something here that I discussed, I believe in the previous video and indeed in the lecture, is the idea that although strength is private, I'm well within my right to simply access it using this dot notation. Okay. So note that if we try to do something like my hero dot strength here, this wouldn't be allowed, okay, because strength is private. But but I'm perfectly within my right to do it from inside that same class. Why is this? Well, if you think about it, we are in complete control of the fight method. Okay, so we are declaring fight from inside the superhero class. So it makes sense that because we're in control of this code, that it's unlikely that we will violate encapsulation, so we will violate the expected values that we have inside our fields in any way that will break our program, because we are in control of this class. Okay, so Java says it's perfectly okay for me to directly manipulate fields when I'm manipulating them inside a different object, so in this case opponent, but it's of the same type, okay, because again I'm still in control of all this code. Okay, if there was a different object passed here, obviously I wouldn't be able to do that, because this is an object that originates from somewhere else. I could be using someone else's object that they've defined, so I wouldn't be able to do this here. But because opponent is of the same type in which I'm declaring this method, I'm fully within my right to access the strength field directly. Okay, go back, maybe listen to me saying that again. If that doesn't make sense, we can talk about it further, but it's sufficient for you to understand that it's okay to access, or you're able to access, private variables in past objects when you're accessing them from within a method that's defined within the same type as the past object. Okay, so I'm fully within my right to do opponent.strength here. Okay. Now, if you were to use get strength here, that's slightly less efficient, so you will have lost maybe 1 mark for this. But that again it's a viable option, but I just think it's nice to demonstrate the idea to me and to your examiner that you understand that it's okay to access private fields directly when it's happening inside the same type. Okay. Now return this isn't actually something that we'd spoken about before the coursework, which is why I left this hint, which was that it might be helpful to know that the keyword this returns a copy of the current object. Okay. So return this returns a copy of the current object. So I know that the current object is the object in which I'm accessing strength. So remember there's an implicit, this here. So maybe this will be clearer. So I know that the strength value that I'm accessing is inside the current object, which in this line here, that's not right. Let's remember that why we couldn't do that, because of the private field. So inside this object here, inside my hero, this is the strength value that I'm accessing. So I know that when I say return this, I'm saying return the current object, which in this case is my hero. Okay, so return this, we'll take a copy of the current object and it will pass it back from the method. Okay, so here we're fulfilling the requirement. Says the winner of the fight is determined by which hero has the highest strength. Okay, and if that, so the only way in which the current object, so in this case my hero, can win is if strength is greater than the opponent's strength. In any other case, then we're going to simply return opponent. Okay, so remember I put this line here that says if 2 heroes have the same strength, then the opponent wins. What I'm referring to here is the passed object, the object that I've passed to this method, which is the opponent. Then in any other case, aside from the case in which strength is greater than the opponent's, so if strength is equal to that of the opponent's, or if the opponent's strength is actually greater than the strength inside the current hero, then I'm going to return the opponent. Okay, so in any other case in which this isn't fulfilled, then I return the opponent. So only if the current hero's strength is greater than the opponent's will the current hero be considered the winner. Otherwise, it's the opponent that's the winner. Okay. Now, there were lots of different ways to do this. You could have explicitly, with an else if maybe, you could have done something like else if strength is equal to opponent.strength. You could have therefore returned opponent here too. So I didn't mind too much if you did this, because it was explicitly stated about the same strength. If you wanted to show me that you knew about that, that's okay. I didn't mind this too much, but note there is some redundancy here, so we're returning the same thing. So we are actually able to capture this case using the else statement. Okay, so else just says in any other scenario, which would actually include this else if scenario, return the opponent. So I didn't, you shouldn't have been penalized for doing this, but it is much more efficient to instead return opponent. And of course, there's lots of variations on this. We could have used, for those who are familiar with it, we could have used the advanced conditional statement, which sets the value, obviously using the question mark colon syntax. That was fine. Or instead, if people wanted to instead evaluate the opponent first, so see, obviously this could have been if opponent.strength is less than, greater than or equal to strength, yeah, then return opponent, otherwise return this. Okay, so to do this the other way around, so to instead say if the opponent's strength is greater than or equal to the strength of the current hero, then return the opponent, otherwise return this. This was also fine. Okay, so it's just achieving the same thing in a logically different way. Okay, but the most important thing here, the if statement is obviously good. It's nice to model this, but the most important thing here is to demonstrate the idea that we're going to return an object, nothing else from a class. Okay, let's talk more about why this is the best way to do things, because I'm aware that people printed things out, people return strings from this method. Let's talk about why this is the best way to do things. Okay, shifted my editor a bit there by mistake. So let's think about this case. Okay, so let's say that we fight two heroes together. So my hero, my second hero. What we end up with is a winner. Okay, so let's specify this. This isn't part of the solution, but this is just for me to explain. Let's say we define a variable of type superhero, and inside here we want to store the result of my hero fighting the second hero. Okay, so if this is unfamiliar to people, remember, because the result of fight is a superhero object, I'm well within my right to take that result and store it inside a new variable called winner, which is of type superhero. Okay, now this won't be a new copy of a superhero, but it will be an existing copy which is returned from the fight method. Okay, so let's imagine that we power up me. Let's power me up to, as I did before, to 1,000. Okay, so we now know, let's go through what's happened. So I've created a new superhero, I've called him Martin, and I've not supplied a strength value, so we know we're calling the first constructor, so I know my default strength is 10. I've made a second hero, I've called him Derek. Again, I've not supplied a strength value, so I know his default value is 10. So before the fight, I power myself up, I receive 1,000 strength, so I know that the result of the fight is going to be me. I'm going to be the winner because my strength in this case would be higher than superhero Derek's. Okay. Now, therefore, the object that would be returned from calling fight on my hero would be my hero. So that's the object that was returned. I want to take this now and I'm going to store it inside winner. Okay. So what I have here is I have a record of who has won the fight. I have a nice record of here. Okay. So let's create now a third hero. Okay. We just can do this arbitrarily. Let's call this third hero Peter. Okay. Now let's imagine that we have or in the future we want to model a scenario in which we have a series of fights. Okay, so first of all my hero will fight my second hero, and we want to record the result of that fight, and then we want to take that winner and fight him against a third hero. Okay, so imagine it's sort of like a winner stays on scenario. So this probably sounds awful, but I will fight Derek, and whoever wins will go on to fight this third hero, which is Peter. Okay. Now, under this scenario, I can do something very nice, which is just call fight again, but with my new hero. So I could do my third hero dot fight winner. Okay, so here I can very efficiently and very easily go along and fight the winner. I've got a nice record of who wins, and I can go along and I can, as many times as I like, fight the winner against a new hero. Okay. Now, admittedly, this is a somewhat contrived example, but what I'm trying to demonstrate here is that it's always nice to return the results of some computation so that it can be useful in the future. Okay, so in this case, it's nice to return who wins the fight, so I have a record of it, I have access to it, and I can use this information in the future. So in this case, I can use this information to have arbitrary fights in the future without having to create extra code or grab variables, grab the values in fields, from different places and use those for a new fight. I can just use these results and store them as I need. Okay, so there's no real hard and fast rule for this as to when you should return values or what type of values you should return, but it just seems you should be able to identify, as you practice these things, you'll be able to identify when it's natural to return objects as opposed to returning anything else. Okay, and the reason that it's natural, let's look in this case what would happen if we simply returned a string. Okay, so I know some people did this, so rather than returning the object, they would instead return name, and then rather than returning the opponent object, they'd instead just return the opponent's name. Okay, now this is good, this is fine. This wouldn't have lost you too many marks for doing this because you're still showing knowledge, you're still fulfilling the requirement that you can somehow get the value back, but it's not the best way, okay? So you will have done very well if you returned a string, but the absolute best way, and obviously remember these assignments are designed to stretch you, they're designed to really give you those maximum marks for identifying the subtleties of what's needed, then obviously you can see that if you return a string here, then we can't do something neat like have a record of the winner. We could have a string here, of course, this would work, but then obviously fight wouldn't be straightforward. What I'd have to do is something like another conditional statement which would highlight who the winner was, construct another object based upon that winner, and then instead take that object and fight it against the third hero. Maybe not even with a conditional, maybe a straight instantiation of an object. Either way, it would be a lot more complex to try and achieve this this new scenario. So it's all about making your code as extendable as possible, making it understanding the idea that your code might be used again in the future. Okay, so the real best way to achieve this requirement was to return an object here, not a string. Although if you did return a string, you should have still done very, very well. Okay, but just for those maximum marks, just for the perfect response, for the perfect submission, returning the object was the best way. Okay, and of course, let's go back to the situation before. Let's imagine this is void, so we don't actually return anything. So instead, what we do is we simply do system.out.println, and we print the name here, and system.out.println, we print the opponent's name here. Okay. Okay. So again, this is, in some respects, in light of what we want to do up here, this is even worse. So we now have no way of returning or understanding who the winner of the fight was outside the fight method. Okay, we're just simply printing the result. So I have no way to grab this information back from the class. Okay. So the best way, the way to maximize your marks was to return something. Okay, and there was and indeed to fulfill the requirement that the result of this fight is the winning superhero, it was you were required to pass something back from that class. These were the best solutions. Okay, and recall that inside these requirements, you were not asked to print anything. There was no requirement to print anything. So unfortunately, in doing so, marks were lost. Okay, and another part of hinting to you that no printing is required is requirement D. Okay, now requirement D was subtle. Some people, I believe, struggled with this to understanding exactly, teasing out exactly what this was asking you to do, but this was all part of hinting to you or trying to help you understand the fact that I did have to return an object in C, nothing else, not void and not string. Okay, because what requirement D asks you to do, it says when a superhero is printed, their name appears on the terminal. Okay, now this is subtle wording. Okay, this is important wording. So this does not say print a superhero to the terminal. It doesn't say print the winner to the terminal. It doesn't say anything about that. Instead, it says when a superhero is printed. So at some point in the future, when a superhero object is printed, their name should appear on the terminal. Okay. So what I'm saying is, let's remove this for a second. What I'm saying is, when I do system.out.println my hero, what I want to happen is I want the superhero's name to appear on the terminal. Okay, so it's not simply saying, and you can see from the language here that's used, it's not saying print a superhero to the terminal. It's saying when a superhero is printed, okay, their name appears on the terminal. So when I do system.out.println my hero, what I want to appear on the terminal is their name. Okay. Now what this was a very strong requirement to use toString. Okay, so we know that if I print an object, so if I print a superhero, note the wording here, print a superhero, without supplying a toString method, all I will receive is a memory allocation, so a hash of the object's memory location in memory, so it will say the class name at that memory location. Okay? So let's see this running. If I run my program, I can run this over here, and we can see that if I print a superhero, so if I print a superhero object, what appears on the terminal is not their name, but instead, as I say, their name of the class and then at this hash of the memory location. Okay, so the only way to fulfill this requirement correctly is to use the toString method. Now, toString was talked about in the context of noughts and crosses. I believe in lectures 3 and 4 it was mentioned. So we know that there is this special form to toString. So when you instruct Java to print an object, the first thing Java will do is it will look for this toString method, which has this very particular form, which is of the form public string toString. Okay? So the reason we have this set form will be hopefully explained in due course, but for now it's sufficient to understand that Java is looking for this actual format. It's looking for a public method with a return type of string, and the name of that string is exactly toString with the case matching as is shown here. Okay, so Java goes through, when you instruct it to print an object, it goes through and tries to identify this special method called toString. And when it does, it invokes this method, it calls this method for you automatically, and what is printed therefore is whatever is returned from this method. Okay, so in this case, because we want a superhero's name to appear on the terminal when the object is printed, all I want to do here is return name. Okay, so I know that to fulfill this requirement, when I print a superhero object, like I've done here, obviously my hero is of type superhero, then I want that hero's name to appear on the screen. And indeed, if I run this, I can see that the result I now get is Martin. Okay, so this was a subtle requirement. It was only worth 2 marks, but it was important because it underpins fulfilling requirement C. Why is that? Well, now we can very easily access the winner of the fight when we return an object. Okay, so let's take this back to being a superhero. Let's change this to instead returning this. Okay, and if the opponent wins, let's change this to returning opponent. Okay. Now what we know we can do is we can do something very, very simple to work out who the winner of the fight is. Okay, so if I have my 2 heroes, myself and Derek, and I want to do my hero dot fight my second hero. Okay, now I know that the result of invoking fight on my hero is a superhero object. I know because I say that every time I call the fight method that a superhero object has to be returned. I make that promise when I create this method definition. Then I know that what I can do is I know that the result of fight will be an object. Okay, so what I can do is I can simply print that result. Okay, so I know that every time an object is printed, I know because I've written my toString method and because I've fulfilled requirement 1D, I know that every time an object is printed that the name of that hero, the name of the hero represented by that object, sorry, is going to be printed to the terminal. And I know that the result of a fight is a hero object, so I can simply print that object and I know I'll be able to see the winner. Okay, so let's go through that again. So I call fight on my hero. Okay, this means Java will find fight inside the copy of this class that's stored inside my hero. Okay, it finds fight, it calculates who the winner is. In this case, because both our strengths, myself and Derek, are defaulted to equal to 10, then Derek will win, obviously, because my strength is not greater than his. That will return the opponent. And so therefore I know that the result of calling this method is an object. Okay, so I can go ahead and I can print this result, which I know is a superhero object, and I know that will give me the winner. Okay, so if I run my program now, it simply says Derek. Okay, so I could do something like this. I could say the winner of the fight is here, and it will print the result. Remember, I'm doing concatenation here. I can run it again. I can say the winner of the fight is Derek. Okay, so what I've done here is I've implemented a nice, efficient solution, which is also extendable. Okay, because I'm not only printing the result inside fight, I'm also printing the result inside. I'm printing the result inside the fight class. Okay, so I'm efficiently combining the use of toString with the ability to return objects from a method to efficiently access who the winner of that fight is. Not only efficient, but also extendable, because I could, if I wanted to, I'm not in this case, I could, if I wanted to, I could assign the result to another variable and then very quickly and very easily have subsequent uses of that method in the future. Okay, so the absolute, the best and most efficient way to achieve this was to combine toString with the ability to return objects to calculate who the winner was. Okay. And obviously, part of the requirement, part of what should have led you to understand that fight should occur inside superhero as opposed to inside the fight class was this final note that said the best solutions will not provide any way of retrieving a superhero's strength from outside the superhero class. Okay, and this was supposed to lead you to understand that something like public int get strength, something like this, which would return the strength, okay, which would allow you to say, go inside here, and rather than having a fight method say if my hero dot gets strength is greater than my second hero dot get strength. Yeah. The reason that I explicitly said that solutions like this weren't the best is because they circumvent this nice fight method, which is reusable, in which I can call, I can use the same method multiple times. Okay, so let's show this in a bit more detail. So let's imagine I have, again, my third hero, yeah, equals new superhero. Whoa, cannot type today, equals Peter, okay. Now let's imagine again we want another fight. Then if I don't have this fight method, let's imagine that I was just using these getters, then obviously I have to now repeat myself. Okay, so I now have to say, if for example I wanted to fight Derek against Peter, which again is an awful scenario, then my third hero, and again, do you see? So I have to, need my getters, get strength, and get strength. You can see here how I'm having to repeat myself now, okay? So by putting these comparisons inside fight, I remove the fact that I have to do multiple comparisons if I purely rely on these getters, okay? So moving the comparison inside here is much more efficient. So rather than having to access strength each time I want to have a fight, so to speak, I can simply contain this code inside one method, and it's much more efficient, much faster, okay? So this is why I said the best solutions will not provide any way of retrieving the strength, because this suggested to you that there was the requirement for a fight method, because this is the most efficient solution, okay? So constructing this code in this way was the bulk of the task. It was the most important part, providing this ability. So again, let's note that at no point are any objects created here. This is simply a class, which is a nice place in which to store information. It has very efficient methods which both accept and return objects of the same type. It has this nice toString method, which means I can print objects directly. There was no requirement here to print anything. There was no requirement to actually fight the superheroes together as a part of this question. All you were doing was constructing this class, which was going to be a template for use in the future. Okay, and this, in this instance, the place it was going to be used is inside the fight class. Okay, so let's empty this out now. Let's stop thinking of me fighting fellow members of staff, but instead let's think about fulfilling question 2, which should have been straightforward. Okay, so there was only a very few marks here because all I wanted you to do was demonstrate the use of this class. Okay, so first one, I've got my superheroes here are Captain America and Iron Man. So let's create a superhero exactly as we should be used to by now. We're going to give it the object a recognizable name. So remember, this won't be the name that's actually pushed into the class, of course. This is just the name of the object variable. So I want to say new superhero, okay? And I'm going to call him Captain America. Okay, so note the difference here. I'm not using the name of the object necessarily to provide my superhero with a name, but instead just to refer to the object. I could do something here, for example, like Hero 1. That would be fine, that would be no problem. It just feels more natural, I guess, to call it Captain America. Then here I'm going to call this Iron Man, so I'm making 2 objects of the same class. Okay, so that's the first requirement asked me to make an object called Captain America. The second one, and note that the first requirement doesn't say anything about strength. Okay, so I'm wanting you to exhibit the fact here that the default strength of Captain America will be 10. Okay. Now, the second requirement, requirement B, requirement 2B, asks you to provide Iron Man with a natural strength. So here I'm asking you to show me that you understand that you can invoke these different constructors. Okay. Now it says make Captain America fight Iron Man. So simply because of this nice efficient system that I have, I can just do Captain America dot fight Iron Man. Okay. Now here it says print the winner to the terminal. Okay, so note the difference here between requirement 2C and requirement 1D. So it actually says print the winner to the terminal. Okay, this is not about providing the ability for printing. It's not about providing. It's not a hint to, in the same way that the one was a hint to use toString, the other requirement was a hint to use toString. This is now actually asking you to do something active. Okay, so to use this class, use this method and the facilities that you provided before. Okay, so make Captain America fight Iron Man, which we've done, and print the winner to the terminal. So it's more than sufficient to simply say system.out.println Captain America fight Iron Man. Okay, so that fully fulfills that requirement. Okay, it's nice to add something, say the winner of the fight, or you could say who fights who. So we could do something nice like we could say Captain America fights Iron Man. We say the winner is here, you can see. Okay, so note here, because I'm referring to an object and because I know all my objects are printable, they will always return the name that you've supplied. I can simply arbitrarily refer to these objects in print statements, and that will return the string version of that object, which in this case is Captain America. So this will actually say Captain America with the space and the capitalization fights Iron Man, again with the space and the capitalization, and then it will print the object that's the winner. Okay, so we can see this running, and it says Captain America fights Iron Man. The winner is Iron Man, okay? Because obviously we know Captain America's default strength is 10, Iron Man's default strength is 20, so Iron Man will win at the start, okay? And then, very straightforward, give Captain America a power-up, Captain America.power-up. Going to increase his strength by 100, okay? And then we're now going to have the fight again. So it was more than sufficient to simply copy and paste the code there. That's no problem. There were no marks for this question. It was just to have a neat solution. Okay. So in the end, our code will read Captain America fights Iron Man. The winner is Iron Man. We've shown that we've used toString. We've used the result of the fight method to print this out. We give Captain America power up and then fight them again and see the result. Okay. This is the solution. There are obviously variants on this, but this is, I believe, the best way to do it, the most efficient and extendable way to do it. Okay, by all means, contact me. We can discuss other potential solutions. If you want me to reiterate anything that's said here. Now, again, I know the issue will be people asking me to specify the requirements further, but let me reiterate that this is a test of your learning, your ability to apply the concepts that you've learned to new scenarios, to pick out the subtleties of a question, and to really become great programmers. Okay, and also remember on the exam, these requirements will not be there in this form, so the requirements should be taken as hints and shouldn't really be expected. Okay. Note also that what we're trying to do here is prepare you to be fantastic developers of the future who are going to make lots of money. Okay, and these kind of requirements you will receive them from clients in the future who want you to build something, and they will obviously not tell you how to do it. Okay, becoming a good programmer is about understanding the best way to fulfill someone's requirements when they're non-technical. Okay, so again, I could have said use a constructor, use the toString method, but again, we're trying to prepare you for a situation in which you are given a very high-level set of requirements, and it's up to you to take these tools and apply them. Okay, do get in contact with me if you'd like to speak further. Otherwise, please make sure you are familiar with all this. This represents the very fundamental understanding of object orientation. Okay, I hope this video was helpful for you.